GK flip-flop, truth table, logic equations. Already we have seen in the last video itself. Next state, ns equal to, already we have seen, j, this is for j here 1, that's why j, ps percent state we have 0, that's why ps for here for this for here this one, okay, k for ps, okay, y equal to ps, y equal to ps, this one, okay. We call more FSM finite state machine state equations. Okay, we call more FSM state equations. X input vector given to combinational logic. This logic name F. Next state. Here after combinational logic, this is the next state. This is this next state connected to register. After register, it will be present state. This present state connect to combination logic, simultaneously connect to combination logic F. This combinational logic name is H. This combinational logic is F. Okay. Here present state only given. That's why we can say this one is buffer. Okay. This is the Y is the output vector. This PS connection given to here, no. This name is called as feedback path. First, this register clock given to here, reset given to here. Okay, now what is the state solution, state equations? Ns equal to a function of f of xt ps, that is this f available from combination logic. In combination logic, what is going on? That is the result. That result is called input to ns. Here, this combination logic for f output is called ns. Here, what is the input? X vector, that is input vector, plus present state feedback given by feedback part. What is this? PS, that's why PS. So here X, this is the input vector, X, that's why X. F is the function which what function is going on? This function going in a computation going in this combination logic. Okay. Then y. In y is the output vector. Okay, y is the output vector. So output vector connection what only? Input what? Combinational logic H1. Okay, what combination going on in combination logic HE? That output is called the total output. So combination logic H function. So that's why H here. Okay, then PS only going to H logic. So here. Okay, so function of the PS in H combination logic is equal to output Y. Okay, output vector. And in JK example, okay, in JK example, this total. Sorry. F logic, this route, okay, this route, this route. Then D register, this one. Then present state, H logic, that is buffer. Okay, that is this one, both. Okay, yeah, both. Okay, then NS, this NS here. Okay, register. Then combination logic F. This is the circuit schematic. This is the block diagram. Okay, so X input giving in this JK. Am I correct? JK. Here in F logic, what is inside? NOT gate, NOT gate, AND gate, AND gate, and OR gate. Okay. In D register, D flip flop. What is this? Reset. Okay. For reset per set, for clear. Here NS clock. This is clock. Here this out, this data coming here. This is the output. This place actually that is buffer. Okay. And that in this JK example, in the circuit schematic circuit, that in what is happening, we will see in the timing diagram. Here this place 500 nanosecond, here 1 microsecond, here 1 point microsecond, here 2 microsecond, here 2 point microsecond, and so on. Reset 1, then after reset it will be 1. Okay, jk has to depends upon input clock 0 1 0 0 1 y is the okay, then jk here input no, so where is given jk input, okay, this one here. And then reset this reset here, okay, this jk input going to AND gate, another one k input going to NOT gate. Okay, this is the feedback. What is this here? Present state giving to as feedback. Okay, so clock is this is the clock. Okay, clock 0 1 0 1 0. After reset it will be 1 only. Depends upon input. Here will be change turn on. Okay. Then y is the output vector. Output, okay, output. So this is up to here 0 1 up to 0 1 0 1. Okay, here 0 1 0 1. So depends upon jk input, here output will get. Here in reset button, after resetting continue 1. In jk up to here 0, okay, 0 up to 500 or 7. Then when it's changing, while negative clock, it is changing to 1. We are giving 1. 1 also same there, output not changing. When it is changing, here only changing. So after 1, no, after in between me, after 1 it is not changing, 2 only it is changing. So here also, here what nanosecond, approximately 900 nanosecond like this. And then here 1 point something microsecond, then 0 output. Here 0 up to what, up to 1.25 microsecond. This will go to up to 1 or 2 for this 1 value. No, for this 2 value, remaining this time delay. This 0 goes up to here, then it will change up for this one value, this one change. This is the time delay. This gap is the no, this gap. This is the time delay for this.